Good afternoon, one and all present here. This is Rishabh Gupta. Today's my topic for presentation is enhancement of dissolution rate of quercetin using solid dispersion approach. I have done my work under the guidance of Dr. Nimisha ma'am. Objective of present work was to enhancement of dissolution rate of quercetin by using solid dispersion approach. Also to study the role of combination of polymers like polyethylene glycol Pg6000 and pluronic F127 for enhancement of solubility of quercetin through solid dispersion approach. Also to study the effect of drug to carrier ratio on enhancement of solubility with different quantity of solvent. The rationale behind this study was that quercetin is a poorly soluble herbal drug and has high first pass metabolism. The particle size reduction to molecular level needs to be done that can be achieved by solid dispersion approach. Also there is need of dose reduction efficient incorporation and potent effect can be seen with solid dispersions. Let me start with the introduction for drug. Quercetin is a chemically known as pentrahydroxyl flavone belonging to the group of secondary plant metabolites known as flavonoids. Quercetin and its derivative can be beneficial against inflammation and also proven as potent anti-inflammatory agent suggested by in vivo models. It has very less oral bioavailability and minimal absorption in GI tract. What are solid dispersions? Solid dispersions can be simply defined as combination of two solid products, mainly a hydrophilic matrix and dispersion of hydrophobic drug, that is active pharmaceutical ingredient in the inert carrier system. Sakiguchi et al. Prepared the first solid dispersion of drug sulfathiazole in carrier urea by melting method. Melting method is one of the method for preparation of solid dispersions. Solid dispersions are beneficial for reduction of particle size to molecular level, hence improved bioavailability. There are some limitations that are associated with the solid dispersion like stability issues, poor scale up and low reproducibility. There are various methods for the preparation of solid dispersion like melt agglomeration, melting method, electrospinning, melt extrusion, solvent evaporation, melt evaporation, supercritical fluid method, lyophilization and use of surfactant. Out of these methods I used solvent evaporation for preparation of solid dispersion during my study. The process of solvent evaporation for the preparation of solid dispersion of quercetin include various steps. The first step is addition of polymers in required quantity. Here the polymers are Pg6000 and pluronic F127. The next step is dissolve this combination of polymers in ethanol with continuous stirring. Then quercetin was added to this mixture of polymers with continuous stirring till a clear solution was obtained. Further solvent was recovered by using rotavapor at 50 degrees centigrade at 50 rpm for a duration of 30 minutes. Characterization. The first characterization is drug content. The drug content analysis was done using UV spectrophotometer. 1 mg of sample of each formulation were dissolved in ethanol and filtered through 0.45 micrometer filter. After suitable dilution, absorption was recorded by UV spectrophotometer. As you can see in the table, SD4 formulation has the lowest drug content. That simply means this formulation require only little amount of active pharmaceutical ingredient to show its therapeutic effect, whereas in SD2 formulation it needs higher amount of drug content to show its therapeutic effect. The second characterization is solubility analysis for aqueous solubility of pure and different formulation. As you can see, there is 5.54 volts increment in the solubility, that is highest of all the formulation that are listed in the table. The next characterization is dissolution studies. Further we check the release profile of all the formulations we prepared, and as you can see in the table at the left, that SD4 formulation at the end of 240 minutes shows the highest drug release of 82.96 plus minus 1.76%, that is highest among all. And same you can see in this graph also, that SD4 formulation shows the highest percentage of drug release. This is 6-station dissolution apparatus that is used during the course of study. Result and discussion. Drug content. All formulations showed a remarkable drug content with mean standard deviation. Among all the formulations, SD4 had the lowest drug percentage, that is 85.50%, whereas SD2 formulation had highest drug percentage, that is 103.02%. The solubility analysis of different formulation were found in the order that SD4 formulation has the highest solubility, whereas SD9 has lowest solubility. SD4 exhibited a maximum of 5.54 fold increment in solubility, whereas SD9 formulation had the lowest, up to 3.31 fold increment as compared to unprocessed quercetin. Same you can see in this graph also. This SD4 formulation shows the highest solubility among all these formulations that are shown in the graph. The next is in vitro release data. The drug release calculated at the interval of 50 minutes, 100 minutes, 150 minutes and 240 minutes, and it is denoted like Q50, Q100, Q150 and Q240 respectively. From the study it can be seen that pure quercetin had drug release of 33.55% at the end of 240 minutes, whereas SD4 formulation showed the highest drug release of 82.96% at the end of 240 minutes. The drug release pattern was found to be in the order of that SD4 shows the highest drug release rate, whereas SD1 shows lowest drug release rate. These are some literature reviews. Like Lee et al. Studied the heat capacity of binary system of quercetin with PVPK 30 prepared by solvent evaporation method. Mass fraction of quercetin less than 0.5 region resulted in the formation of amorphous solid dispersions when using drug carrier ratio of 1:2. Ghanem et al. Prepared the solid dispersion of quercetin with PVPK 30 and PF 127 by spray drying method. Solid dispersion of quercetin with PVPK 30 in the ratio of 1:1 and PF 127 5% weight by weight was most promising one. After the end of 60 minutes, formulation showed 95.1% release. Also, the formulation were of high energy amorphous state as revealed by DSC and PXRD studies. Likewise, there are few more literature reviews that are listed here. Hence, I conclude my presentation with few outcomes like solubility of different formulation were found in the order of SD4 has the highest solubility, whereas the SD9 has the lowest solubility, in which SD4 exhibited a maximum of 5.54 fold increment in solubility. Percentage drug content of SD4 formulation was found to be 85.50 plus minus 0.34%, and the percentage drug release of SD4 formulation found to be 82.96 plus minus 1.76% at the end of 240 minutes. It also results in enhancement of dissolution rate and solubility of quercetin by solid dispersion approach. It can also be concluded from this presentation that PG6000 and pluronic F127 in definite proportions were helpful in enhancement of solubility and dissolution rate of quercetin. These are references that I have gone through during my course of study. Thank you.